All right, so why do users, in the first place, have multiple clusters? Now, there's multiple reasons, valid reasons for this, and Justin shared across some of them. But you might have clusters from a governance perspective. You're using multiple clusters, have multiple teams, have multiple applications. You're doing it from an isolation perspective, where you want to have hard isolation. You might have hard kind of tenants that you want to separate, and you're putting that across different clusters. You might be doing it for regionality. So you have a cluster in East US, a cluster in North Europe, a cluster in, in Brazil or in some other region to serve customers in that region, your customers in that region. You might have different clouds even, not just regions, but sovereignty regulations, maybe some sovereign clouds like in China or the US government cloud. So there's a lot of reasons, very valid reasons, to grow your estate of clusters and not just, as Justin mentioned, maybe you can grow to 5,000, that's good. But there's still many, many, many cases that will actually push you, and correctly so, to have multiple clusters. Now, and that's not surprising that we got this question this morning on, okay, so what are we doing there? Because the thing is, when you start growing, you start to have some challenges. And despite a lot of our work that Justin kind of covered about how to operate, I guess, kind of at scale, meaning not just large clusters, but a large number of them, there's only so much you can do as an operator, as a platform team, without then having to be commonly reinventing the wheel, right? Because there's a lot of common operations and common cases that you want to benefit. Can I have something that helps me orchestrate life cycle across this? Can I have something that helps me spread my workloads or not spread them or put them in different regions? How can I serve as a platform team, which I kind of heard this morning a lot of you are, serve my business units and my developers a bit better, especially like they don't want to know and be deploying themselves and creating more pipelines across all these different clusters. So how can we kind of address some of these challenges that span from identity to networking to lifecycle management to governance? Now, on AKS, you already see a lot of efforts in this area. I think this morning, one of you, I believe it was this gentleman at front, were mentioning GitOps. Now, a way to do configuration spanner across multiple clusters could be to have a common repository and just ensure that you have the GitOps agent in all these clusters. That's a way you can synchronize configuration like that. You still need to ensure that that's installed, and that solves only one of these challenges. You still have many more. Now, on identity as an example, you could use Azure RBAC, the Azure RBAC integration with Kubernetes that we created that allows you to specify, identity and access management through Azure and put that, for example, at the subscription level or even higher at your account level, meaning that all your clusters are managed through Azure RBAC. What that means is you can very easily go and say, I want my developer team number 1 to have read access to all clusters, no write. And you can get them by default. So every cluster that comes up, that developer group or that individual has read access to all clusters. You can even go beyond that because we actually took the work to project namespaces into ARM, to Azure Resource Manager, and you can actually say, I want my developers to have read access to all clusters and write access to dev1 namespace. And so in all dev1 namespaces, across the scope that you define, which could be, all those clusters, those developers will have write access, but only to that namespace across all those clusters. So there are several things. Policy is another case where you can have policy done across many clusters and applied automatically by Azure that will automatically install Gatekeeper and automatically push those policies in. So again, we've taken some approach to simplify and enable all these use cases. But again, it didn't solve everything. So really, Kubernetes Fleet Manager comes to complement, to leverage all these things, obviously, but to complement and add on the existing gaps and in some future gaps that we're currently working on. So one, obviously, is lifecycle. As you want to make sure that you're managing lifecycle. A lot of you, I know, are probably using a number of automation tools that are great for this, and that's perfect. And if you're happy, you should definitely continue to be happy. That's how I want you to be. But if this is a struggle already for you, you can further enhance your automation by leveraging Fleet and leveraging automation with Fleet. Not just that, workload placement. Once again, you could be leveraging something like GitOps or something like automation also from Terraform or Bicep or Pulumi or any other these great providers. And you could also be wiring that up yourself. Then you might have to ensure and have the guarantee yourself that there's no configuration drifts, that you're being able to get there. It makes it pretty hard to be doing resource placement constraints. Because when you're looking at your whole fleet, then you actually need to put on your pipelines or in your automation, okay, workload 1 goes there and there, so that pipeline needs to know. Workload B goes there and there, so that needs to know. So you're kind of almost reinventing a little bit of what Kubernetes scheduling actually does. So due to all of that, Kubernetes Fleet Manager is actually a Kubernetes cluster that is actually acting as your hub, as your fleet brain, if you will, as your fleet control plane, which is literally what it is. So you can actually go back into all that you already know. Oh, I use affinity or selectors for nodes and for node pools. You're gonna go and be able to design for fleets. So you expand all that you already know, and you leverage that now not only to treating kind of your nodes as cattle or whatever better analogy there, but actually even your clusters themselves. So, what does it look like and how does it work and some of the key capabilities? So the first thing is, for a fleet, you want to create a fleet resource. As I mentioned, that's a Kubernetes cluster that acts as this hub, as this control plane for the fleet, and allows you to, again, specify the configuration, do the workload placement, and much more. And then you want to join the respective member clusters. You can actually have multiple fleets. That's a different rabbit hole that we're not going to go in today, but you could very well eventually have multiple fleets. You'd add the different members into these different fleets. So in this case, member A, B, and C. Now these different members, for the use cases that we talked about, can be in different subscriptions. They can be in different regions, all the same. You can mix and match. As long as it's the same tenant, you can add them from wherever and whenever. Now, one common use case that I mentioned is the case, for example, for platform teams to actually provide, say, a fully configured space, namespace for their users, their developers, their customers sometimes to use. Again, you can leverage self-built automation or GitOps to do some of this, but it's still pretty challenging to do so in ensuring the correct, again, placement and constraints to ensure that every new one has it, to ensure that only the specific ones that you have. Once you get more complex and you have different rules, maybe some team is only allowed to be in some regions, other teams in other regions, different configurations, it becomes really complex. With Fleet, you can very simply just create a cluster resource placement. And basically, in this case, it's a namespace, as you see. So the kind, the version, etc., is the exact same APIs that you know from the Kubernetes resource itself that you would find in its own manifest. And then you can actually drop affinity. And you might, again, would be very familiar with node selectors that allow you to say this pod goes in this node, or nodes that look like this, have this label, whatever the characteristics are. In this case, you have a cluster selector. Again, same concept, but now instead of just saying, I want this namespace or this pod, in that case, to go into this node, you're saying, I want this namespace with this configuration, maybe these resource quotas, whatever configuration you're preparing for your team, is going to land, in this case, on this location. So you want to make sure that this is in East US. All right, so the next step now is load balancing, which is okay. So maybe now we're able to more easily get things across into multiple clusters, into multiple regions, but how do you get that going? And you might be doing this today, many of you, and I've talked with some of you, you're already doing some of this today by leveraging Traffic Manager or Front Door or similar things like that enable you to do it. The key thing we wanted to make easy is, again, to avoid you from having to kind of build that up yourself and to maintain that and to kind of cobble it together. Totally fine to do it. You already have it working and you're happy once again. Fantastic. But in many cases, especially at runtime, and as you add more things, it can get challenging. And it's sometimes better to just replace that with the Kubernetes kind of reconciliation system which is what the hub gives you. So you can very easily, in this case, create a multi-cluster service and then make sure that it's deployed in the clusters that you want. So it's going to have its own version. So inside each cluster, in this case, it's going to be member A and member B, or member B, member C, depending on what your constraints are. And in that cluster, you're going to have the two native services that you know, just deploy service with the right information, but those were deployed actually by the fleet. So the fleet automatically, you just set it once, get me a service running in East US or in West US, and the fleet manager went on and deployed them in the right place. But okay, so now you have local services. So are they just going to create a local load balancer? That's not what I want. I want access to it. So we create a global load balancer and configure it for you that then points into these local clusters themselves. So you get one endpoint for this workload, because this is a scenario where the workload is the same. You could very well be doing different. So in the fleet manager, you say, I want just different workloads in different clusters. Totally fine, totally flexible. But in this case, when you're trying to have workloads across regions, you can actually very easily just say, hey, get me this workload in each region and get me a global load balancer and put it there. And it's very, very simple as this. Let's take a look. See some of you looking in disbelief. So let's actually see this in real time. So the first thing that we're going to do, this is, again, the Azure portal, where you just saw me start from before. And hopefully I started. Maybe I did not. I did not. There you go. So from the Azure portal, we're going to go ahead and go into Fleet Manager. And first thing that we're going to do is we're going to create a fleet, and we're going to add some member clusters into it. And so creating a fleet is very Azure standard. For those of you that are using Azure, just going to give this resource a name, just going to get it created. Again, this is a Kubernetes cluster. In fact, this is an AKS cluster. So it gets all the benefit from that fast creation we mentioned before. And we'll go ahead and add these 3 member clusters. You'll notice 2 in East US and 1 in, I think, West Central or similar. The next step is these clusters are going to register themselves with the fleet. All right, so we can just jump now into our fleet resource, and we can just browse our member clusters, and you'll find these 3 clusters there. So now is where the fun really begins. So first thing we're going to do is we're going to make sure that we have that Fleet Manager RBAC cluster admin, which again, leveraging already the Azure RBAC capabilities. Now we have this fleet admin that is able to do this. This ensures that you're able to actually do commands against the fleet hub, because you might not want just every individual person to be able to do this. And then you're going to get more granular things of what you can do naturally, like with any Azure RBAC capability. The next thing you're going to do is, because this is a Kubernetes cluster, you're going to get credentials. And that might look very familiar, like an AKS cluster. That's exactly what the intention is. So you're going to get the fleet credentials, and you're going to be able to list the member clusters, all correctly joined. Now, the next thing we're going to do is we're going to deploy a very familiar, hopefully, manifest. So you see a namespace, you see a deployment, you see a service, and the only key difference that you're going to be seeing here is we're deploying also that service export. And we're adding some specific constraints into where we want this to be deployed. Those are the 2 differences from your absolutely standard YAML manifests. So we deploy that. Now here come the resource placement constraints that you saw before. So you see, we want this to be placed in that namespace, demo, and we want this only on East US. Now remember, we had 2 clusters in East US as members and 1 in West Central or West US. So now we're going to just deploy this, and I think not spoiling anything for you, but the expectation is we're going to get that service, those pods, those deployments, those namespaces deployed in the East US clusters and not the West US. And because this is a service and we have that service import and export, we should have connectivity via a global load balancer to the workloads on both. So if we very quickly look at what's on cluster number 1 and cluster number 2, which are the east-west ones, you'll see the service and the deployment all running as expected. If you look at cluster number 3, which is not in east-west, then it has nothing. And when you even list your namespaces, they also don't have the demo one because it's not in east-west. Now let's actually get the service going. So we deploy the service export, which allows you to say, hey, export this service for me from a local service. So now you have 2 little services running in each cluster. How do you make this global? So you deploy this multi-cluster service that, again, in a very Kubernetes native way, just points to the 2 individual services. And what you see here now, in short, notice the request address there. So you see 10.1.4, 10.1.4, and then you see 10.15, 10.23. Actually go back a bit so you're able to see it. Maybe I'm not able to go back since I'm not getting this. But you see 10.2.23, 10.2.24, 10.1.15, 10.1.17. Those are actually the host names. So those are the pod IPs, and those are the host names that you were seeing as we were deploying. And I don't think I get to do this. There you go. I'll let it run a little bit more. And before we go into roadmap, I'll point it out again when we get to the IP, so you confirm that you now have a multi-cluster IP. So before we go to roadmap, I want to pause for a second and see if you have any questions so far. Does this make sense? It's aligned with what you're expecting? Any key things? Okay, 2 questions. Corey, where do we have the mic? Right here. Let me jump into you there.
I go here.
Oh, you got one first.
Hey, good afternoon.
Yes.
First question, I got a few questions, just short questions.
Go ahead.
Can I change the load balancer type, or is just embedded on whatever you got over there? Is like, for example, if I wanted to add like a front door, for example, or something more robust.
Good question. So that ties into my next slide. So I'll answer that on the next slide.
So the other one is, if the fleet manager a global resource, so that means if I try to, I'm setting up like a redundancy stuff over there, and a region goes down for a reason, so my fleet manager goes down over there, so meaning I lose the connectivity, my entry point?
Good question. So the answer today is it's original. That also is on my next slide. So the very good questions. Okay. You get one of the signed books afterwards. And we actually are working right now. So before GA, this is in preview, and before GA, this will be, it's already a fully managed cluster, and we're going to make it a region resilient. So if a region goes down or anything goes down, your fleet endpoint doesn't go down.
Last question is, those nodes that I'm adding over there, the other clusters, have to be pair regions as well, or can be different regions, totally, completely different?
There can be any regions whatsoever.
Can be like from America to Europe or Middle East, whatever, Asia. All right, thank you.
Yeah, sure. I think there was another question here at the front. Let me see if I don't miss when we get back into the addresses. Thank you, Corey. Yep.
Yeah, I had the same question about the sort of whether this actually belongs on the control plane kind of area. But did you consider contributing to cluster API instead of going this direction with kind of bespoke aspects to your manifest?
Very much so. So the cluster lifecycle management that we're talking about is very likely going to be, so we, and I think might have in the room even some of the folks that work on kind of CAP-Z, which is the CAPI for Azure, so cluster API for Azure. And a lot of the management that we're looking at here right now is actually either leveraging or going to leverage cluster API. So we see that as the lifecycle management for clusters, and this is kind of more the brain where you send instructions for. So CAP-Z is, in the best way possible, the implementation detail for a lot of these things.
Right, and just kind of to follow up on that, like the reason for that question was kind of shouldn't the information about like which ports you're exposing through load balancers sit with the application more than the operational side of things? Is that something that's currently exposed through like through CAPI?
I'm not sure I followed that one there. So on the first part, I definitely agree. Like the port information, et cetera, on the services as an example should absolutely be on the application side. That's why we're deploying it via the manifest like multi-cluster service. And there we go. Thanks for the point out. So just a quick pause to see if you look at the left-hand side, you'll see the 1015, 1023, 1015, just right after that red piece. And so you see 1024, 1023. So as we're hitting that endpoint, it's going through that global load balancer into the various clusters that we have here and even various regions as well. And so you can now see the rest and confirm that are the same IPs. So to your point, absolutely, I would say that things like port management should be in something like the manifests that you're deploying. So in this case, we have the multi-cluster service manifest, which is based on service import-export. That is an upstream project. And so everything that we're doing in here is 100% open source. The only key things I think that we added here is the workload placement piece is the only one thing that we're contributing now back into the open source community. It's already open source, but we're trying to contribute back. Everything else is really just built on already existing pieces like CAPI or service import export. Later on in the next slide, maybe I'll go forward more, ties a little bit of your two questions, which is what about L7 and other options? And that one is built on top of the Gateway API, which is also yet another of the key projects that where ingresses are moving forward to, if I may do that analogy. And same thing with multi-cluster service mesh and a lot of the options that are already out there in the community. So absolutely. Any more questions? And I'll just leave the slide there since I think now you're going to go read through it and get a bit more questions. All right, we got the next one coming.
So it's based on a global load balancer?
Yes. So today the solution that is there is an L4 north-south solution. We are currently working on a L7 load balancing solution. You could already use some of existing ones that you could even install, and we could go with that approach, like having something like any ingress controller that supports the Gateway API and deploy that. So we could do that, but we actually want to, again, save ourselves the trouble and save you the trouble and actually have this being something like the global load balancer, but also for L7. And so we're working with the networking teams from Azure to actually create an L7 resource that is cloud native and supports this, and that we're going to be launching hopefully shortly to actually support this thing. So it implements the Gateway API. It does L7 load balancing, again, same things that you'd expect from this.
So the reasoning behind my question is around the desire to be able to have multi-region automatic failover for private addressing.
Yes. And private IP is absolutely the top scenario that we're going to definitely support. I think we got a next one right afterwards. I got another one there. You got the mic right there. Yes.
Yes. Just wondering about the ARC-enabled Kubernetes.
You're making my life too easy. You're just going
clusters.
straight into all the questions. We don't know each other, right? So ARC-enabled Kubernetes is a super important thing. So I talked this morning about the ability for you to today now deploy AKS, not just the cloud, but also at the edge, like on HCI and Azure Stack HCI as an example, or Windows IoT, and any of the AKS hybrid deployment options. You can also enable pretty much any Kubernetes cluster to be ARC-enabled and be able to deploy some of the things that I mentioned, like policy, like GitOps agents. Now, what ARC actually allows you to do is it creates a bridge from that edge cluster and kind of makes it an Azure representation. What Fleet gives you is management of Azure Kubernetes clusters. So what I just said here was you're going to be able to, right now it's just AKS cloud clusters, but we're currently working on right now to get any ARC-enabled cluster into Fleet so you can manage both of them consistently using the same way. So you have, as I showed today, East US, West US, and you can have HCI as well, and you could do all these things, workload placement, et cetera, across them.
So whether it's AKS or not, you'll be able to utilize that.
Sorry?
in ARC. So you're saying that you'll be able to use ARC with whether it's an AKS cluster or not? Or
Yeah, absolutely. So you can already use ARC today. You can ARC-enable any Kubernetes cluster out there and deploy the policy, GitOps, et cetera, today there. You're going to be able to use AD authentication and authorization as well. What this is now going to enable, one of the key things that when ARC joins and enables your cluster, it creates a representation on Azure. So with that, you're going to be able to just join that straight up to your Fleet, that will deploy and will do the necessary registration, and then it will enable Fleet Manager to manage it as well.
Okay, we'll take one more question while
One more question.
Michael gets set
You're the
up.
boss.
Pardon me, so around the global load balancer, unless I missed my guess, what is that based on? Is it based on Traffic Manager today, or?
No, it's based on GLB, which is actually a SKU that Azure has called Global Load Balancer, hence the very non-creative name.
I learned
So-
something, okay. Thank you.
So GLB is L4, like if you know the Azure Load Balancer, GLB is just an Azure Load Balancer, just that actually is global. And also have more. Okay, you said last question. So again, we're going to have a final session at the end of the day where it's just going to be two-way conversation. So any questions that you have, please just take note of them, and we'll be glad to take them. And anything that pops into your mind, just bring it up later. All right, Michael, you're up.